Hello and welcome. My name is Partho Majumdar. In this video, we will understand the clustering model. So far, we have been discussing the supervised learning model, and now we will discuss a unsupervised learning model. Now, unlike the supervised learning model, in unsupervised learning, we only have the data. We don't have any labels for the data. So the raw data is available and we expect the machine to understand the data and create some solutions for us. One such problem which the machine can solve for us is known as the clustering problem. So supposing we have some data like this, we expect the machine that you make clusters out of this data. Tell me that these data points are similar, these are similar, and these are similar, and this is similar. So this, when the machine does this kind of a job, it is known as the clustering job. So as usual, we will try to understand the clustering solution using Excel, and then we will go on to Python where we will solve a real problem. So here we are in Excel. We will go through the mechanics of how clustering is performed. Clustering, like we discussed, is an unsupervised learning job for the machines. Now here we have the data regarding some customers. So there are 10 customers and we have the data regarding when they made a last purchase and what was the value of the total purchase they made during, let's say, the last 1 month. So this is the data we have. Based on this data, we want to classify the customers into different classes. So we do not have any other data regarding these customers. Now this analysis normally has 3 parameters. One is the recency, frequency, and monetary value. This is a very popular analysis in marketing management. We will take only 2 parameters, that is recency and monetary value, because we are using Excel and we can only display data on 2 dimensions. So from this data, let's say this is the data we have, and let's say our reference date is today, the day of I'm recording this video, that is 9th of October 2022. So as on this date, we can calculate how recent was the last purchase of the customer. So I call it recency. So recency we can calculate. Recency is nothing but the date of reference minus the date of last invoice. So I will get the recency of all the data points. So there we have. And monetary value, we already have it. So we just take it away just like this. This is, let's say, our monetary value. So we just have this data. So we have the data regarding recency and monetary value. Based on this data, we want to classify the customers or cluster the customers into different clusters. Now to start clustering, we must tell the machine that how many clusters we want to form. Okay, there are other mechanisms and mathematics by which we can find out what would be the ideal number of clusters. We will not get into that right now because we're learning the basics. So we must tell the machine how many clusters we want to form. So to start with, let's say we tell the machine that we want to form 3 clusters. So we will say we want to form 3 clusters, and the clusters are, let's say, A, B, and C. So we want to form 3 clusters, and for the clusters we must give him some starting points. We must tell him what would be the starting point. So to understand this concept, let us plot this data first. So let us plot this data. So I say insert a scatter chart like this. So here we have it. So this is the recency and monetary value of customers. Okay, so we have this chart. We see that the data is scattered in this manner. So from this we want to form 3 clusters. So we tell the machine that we want to form 3 clusters of these customers. So we must tell the machine that what are the starting points. So arbitrarily we choose some starting points. Let's say the starting points are 15 for recency and 1000 for monetary value, one starting point, 25 and 3000, and 50 and 5000. So we tell the machine that your starting points are these values. So let us plot this data on the chart as well. So let's go here, select data, we add another series, and the series we will give it a name here, and we say the X is this and the Y is this. So there we have our data. So I will just name this centroids. So let me just put it here. Okay, so now you see that the centroids are colored in a different color. So we have chosen 3 centroids at arbitrarily. So now what the machine will do is that try to figure out which point belongs to which centroid. So this centroid, we are going to say this is class A. This centroid we're going to say class B, and this centroid we're going to say class C. Now the machine has to figure out these data points belong to which of the 3 clusters. That is, which it is aligned to which of the 3 centroids. Now to do that, what the machine does is that it tries to figure out the distance of each point from each of the centroids. Okay, so we have to figure out the distance from the centroid. So it's a distance from A, distance from B, and distance from C. So I will just, okay. So we need to figure out the distance. Now the distance of 2 points, we know it by geometry that it is nothing but, supposing this point is x1, y1 and this point is x2, y2. It is nothing but x1 minus x2 whole square and plus y1 minus y2 whole square, and we take the square root of that. So we can find the distance from A for all the points. So we say this is nothing but x1 minus x2. So this is going to be fixed whole squared plus y1 minus y2 whole squared, and the whole thing will be square root. So this is the distance we find it. So I will remove this, make it general. Okay, so now we have found the distance of this point from A. Let us find the distance of this point from B also. So let me just copy it and then change the formula, that will be faster. So this is nothing but this H2 will change to H3 and I2 will change to I3. Okay, so this is the distance of this point from the second centroid, and the distance from the third centroid we can just change this. So this is H4 and I4. So now we have the distance of this point from the 3 centroids. So we similarly calculate the distance of all the points from the 3 centroids. So there we have it. Now the next step is that the machine, what it will try to do is it will try to find each of the point it is closest to which centroid. So for example, in this case, this point is closest to the centroid A. Similarly, this point is closest to the centroid A, whereas this point is also closest to the centroid A. This as well, this as well. I think we are doing something not so correct. Let's just verify once again. E7 minus H2, F7 minus I2. Yeah, our formula is incorrect. So this has got to be E7. So I will just make a change here and then copy. Yeah. Now let us copy this formulae across. Yeah. Now see that this point is closest to centroid A. This point also is closest to centroid A, whereas this point is closest to centroid C. And this point is closest to centroid A, this is closest to centroid A, this is closest to centroid B, and so on. So we have found which points are closest to which centroid. So now, based on the distance from the centroids, we can formulate a cluster. So we say that if the distance from A is equal to the minimum of the distances then it is centroid A. Otherwise, if the distance from B is equal to the minimum of the three distances, then we say it is centroid B, else it is centroid C. So this one happens to be in cluster A. Let us find out the other points. So now you see that we have got one level of clustering performed. So we have this point in cluster A, cluster C, A, B, C, and so on. So the initial clustering has been done. However, this may not be the optimum. The machine will try to optimize it. To optimize it, what it does is that now he has got these centroids which we have given him as the starting point. He will try to recalculate the new centroids based on the distances what he has got right now. So for doing that, what he will do is that, so here we say new centroids. New centroids. So to find the new centroids, what it will do is, it will say this is equal to the average of the original centroid and the average of all the points which are currently belonging to this centroid. So out of these points, the points which belong to cluster A, I will take the recency figures of that and calculate the average. So here we have this point H2, and we are going to take the average of all of these points, and this is 16, this is 16. Why is it less? 760. This has got to be 16. Okay. So this is the. This also we hard code it. Okay. So now he has found a new centroids. So now I can calculate the value. I will just copy and then see if the formula is not correct. I will rectify the formula. So let us see this. There is something wrong with the formula. Okay. So here this is nothing but average of I2 and L7, this is also okay, is equal to H2. No, this is not correct. This has got to be G2. And rest is okay. So now you see that he has calculated new centroids for the clustering. So now let us see on our chart, if we plot the new centroids, what do we get? So I will change this. This has now become this centroid, and this has now become these points. So you see that the centroids has shifted based on the calculation what he has made. We will just recheck our calculation once again. This was okay. This is nothing but I2 and average if this is equal to A, that is G2, and E7 to E16. Correct. No, this is not correct. This has got to be F. Yeah, now it is okay. So I will just copy this down. Okay. So now you see that we have the three new centroids. Now our values are correct. Okay. Now this is a new centroid. Maybe it is better. Let us find out the distances once again and check whether we are closer to the solution or not. So let us recalculate the distances. So here again we go. This is nothing but this minus this. This is dollar raised to the power 2 plus this minus this dollar raised to the power 2, the whole thing raised to the power 1 by 2. Okay. Yeah. Now we will just copy and then correct the formula. This has got to be equal to, this is not F7, this is E7 minus N3, and this has got to be this minus O3. So this is okay now, and this has got to be equal to this, and this has got to be equal to this, and this is N4, and this is O4. So we have the new distances. Let's copy this. So now we have the new distances. Again, let's put our formula in place. So I'll just copy and then manipulate the formula. This is got to be equal to minimum 07, not 07. This is, sorry, this is N7. N7 is okay. And this is got to be change. This is got to be this. Yeah. And then it has got to be G2. This is okay. Or 07 is equal to minimum. This has got to change. This is coming here. Yeah, now it is okay. So we can copy this across. Okay, now see that there is something maybe not so correct in this. N7 is equal to minimum of N7 to P7. NOP, correct? Then it's G2, or 07 is equal to minimum of N7 to P7. That's correct. Then G3 or else G4. What is this? N8, 08. There is something wrong in this formula. Ah, right. Got it. 1 minute. This has got to be this. Okay. Now if we copy, we will get the right. Okay. Now you see that the clustering has been done once again, and the values are not very different. There is some difference. Like for example, this point was in cluster A, now it is assigned to cluster C. So there is some difference. So it is reclustering, it is recalculating the distances and clustering once again. So let's repeat this exercise one more time and see whether we get a change of clustering. The machine will do this activity many number of times till it finds a stable solution. The stable solution is basically when the clusters of different points do not change over iterations. So right now they are changing. So the machine, we will not do so many times. We will do one last time, and then let us close this. So I just copy this to here and recalculate the centroids. So the centroid now is N2 and average if L7, not L7, this has got to change. This will be these values. So this is dollar, and this has got to be $G, and this is okay. So this is fine. So I just copy this. We will change the formula if it is not okay. So now let us check this. This is this value. Sorry. This is O2 average if this is equal to G2, and no, this is not okay. So this has got to be F. Okay, so now we have our new centroids. So now let us plot these centroids on our data and check whether there is a shift. So now the centroids are here. I change these values to this and change this values to this and say OK. So you see the centroids have shifted once again. So now again we let us calculate the distance of each point and then try to figure out whether the clusters have changed or not. So I will take one formula and then try to change it. That will be easier. So I take this. So this is now got to be not J7. This is got to be this minus this will change to this. Let me just fix this. And this will be this point minus this will be this point. Okay. Something wrong with the formula. One bracket is missing. Okay, so now let us copy this across and recalculate this formula. This is got to be equal to, this is E and this is F and this is 3 and this is 3. And let us calculate this. This is got to be E and F and this is got to be 4 and 4. So now we can copy this formula for the rest of the points. Again, let us try to calculate the clusters. So I will copy this and make modifications on top of that. So this is got to be N7, no, S7 is okay, and this has got to change to this values. Let us change here, this is simpler. 7 we will not fix, and we can copy this. Yeah, so now this formula is okay. We can copy this formula across. Now you see the clusters are again assigned, and seems like the clusters have not changed over the last iteration. So to basically get the idea, like, you know, what do you call, we are continuously going to be changing, calculating the new centroids and seeing whether each of the points are closest to which point. So this is a very powerful algorithm what we have just discussed. This is called the k-means algorithm. Now we have seen this on a 2-dimension. So let us go on to a real data and check this out on Python, where we can visualize in 3-dimension. We will take a 3-dimension data and visualize it on a 3-dimension. And we don't have to go through the pains of entering formula in Excel. We can write code and get it done.